So now let's start with the topic called sinusoids. So we already know the definition for sinusoids. So the signal having the form, so let it be sine or let it be a cosine function. We generally name that particular function as sinusoids. So we have both sine and cosine functions. So more often I will take sine function for many of our problem definitions. So we will be solving also for cosine functions, but I try to take examples much for the sine functions. So if you take this waveform, okay, so we can clearly write or represent this particular waveform in terms of this equation. Okay, so this is your thing which is going to tell about the amplitude, basically the voltage, and this is the x-axis represents your time. So altogether, this particular function, the v of t altogether is defined as this. So Vm sine omega t. So where Vm is representing the amplitude. So here the Vm is this. So the amplitude. So we have both positive and negative amplitude. So we have positive Vm and as well as negative Vm. Okay. So it's generally called as Vm sine omega t. So where Vm represents the amplitude, the sine represents the type of waveform it is undergoing, and as well as the omega represents the natural frequency, and t represents the time. Okay. So we also represent this particular function as same as like for the cos. So generally we represent for cos, we replace the sine with help of cos, and this particular functionality will change. So maybe it will start from the other axis. So whenever you take this particular example, we generally find the another thing called time period. So we say it as the fundamental time period. So what is the fundamental time period? So this is the thing where the waveform generates and it starts with 0, and after one full cycle, the one full cycle represents both positive and as well as the negative wave. Okay, so the positive cycle and as well as negative cycles together form the complete cycle. So from 0 till the time period t. So this is the minimum time period required for the one complete waveform to complete one complete waveform. So this is the time period t. So in order to complete this particular waveform, it requires t times. Okay. So this is nothing but the minimum time required to complete one cycle is called as fundamental time period. So this fundamental time period is denoted by capital T, and similarly whatever it is in the middle we generally say it as T by 2, half time period. So at the half time period it is at this particular axis which is actually 0. Then after that it remains at T, it is meeting at 0. So similarly this particular waveform gets repeated over the entire time period. So this will go from minus infinity to infinity. So this is the entire time traveled by this particular waveform. So this nature of waveform will never get altered, even if it is going for the negative infinite range or to the positive infinite range. So this particular thing defines your periodicity. We name that thing is called as periodicity. So that's why we say the periodicity as the periodic signals. So the signals which are repeated after some time period, okay, the time period is denoted by t. So maybe after t of n time period, this particular signal gets repeated. So we generally represent those periodic signals as, so let's say, so this is the signal. If it is getting repeated in the other negative or infinite range, let's name that as n into t. So where n represents the integer, So it could be positive or negative. So where it is actually happening. So it could be till infinite range, negative infinite range. Or this integer could also be positive, which may happen at the positive of your x-axis. Okay. So generally, this is the thing which we generally go through. So it is represented as v of t plus mt is equal to v of t. So how it came? So generally just keep things in mind. So what is time period? Nothing but minimum time required to complete one complete cycle. It means both positive and negative cycle. And it goes from minus infinity to plus infinity. This signal will never get altered. The shape of the signal will never get altered before the negative side, before the negative x-axis or the positive x-axis. This thing remains same. And this represents the periodicity. Okay. The periodic signals is generally given by this particular form. So what is the definition of this form? So even after the shifting of signals, after some time period, so n time period, so it could be positive or negative time period, but after some time if you keep on repeating the signal, it remains as it is. So that is called as periodic signals. And generally periodic signals should undergo the symmetricity. So it should be symmetric in nature.